Dear learners, it's a second part lecture of the simple harmonic motion. The displacement of a simple harmonic oscillator at any instant t is x equal to a sine omega t plus delta. Let us see the variation of sin theta with theta. Here omega t plus delta, it is theta. The variation of sin theta with theta is shown in figure shown here. As theta rises from 0 to pi by 2, sin theta rises from 0 to 1. Theta rises from pi by 2 to pi, sin theta falls from 1 to 0. Then, as theta rises from pi to 3 pi by 2, sin theta falls from 0 to minus 1. And when theta rises 3 pi by 2 to 2 pi, then sin theta rises from minus 1 to 0. Then when theta rises twice pi to 5 pi by 2, then sin theta rises from 0 to 1. That is, sin theta repeats at theta equal to 2 pi. Here sin theta, here at this point sin theta repeats itself. The maximum value of sin theta is 1. In a similar manner, x equal to a sine omega t plus delta, x varies from 0 to a. The maximum value of x is a. So x is also a periodic function like sin theta. X is a periodic function of time. The maximum value of x, that is the maximum displacement, is called the amplitude of the simple harmonic motion. Here A is the amplitude of the simple harmonic motion. The toy car is a simple harmonic oscillator and its motion is called simple harmonic motion. The period of a simple harmonic oscillator. We know the displacement of a simple harmonic oscillator at any instant t is x equal to a sine omega t plus delta. The velocity at that instant is v equal to dx by dt, that is omega a cos omega t plus delta. Omega is the maximum velocity. Therefore, v equal to v max cos omega t plus delta, and acceleration a equal to dv by dt, which is minus omega square a sine omega t plus delta. Here is minus omega square a. It is the maximum acceleration. The negative sign indicates that it is opposite to the displacement. So A max sine omega t plus delta. X, V and A repeat if omega t plus delta, that is theta, is increased by twice pi, 4 pi, 6 pi, etc. That is, they repeat if omega t plus delta is increased by at least twice pi. The repetition can be shown here in this way: x equal to a sine omega t plus delta plus 2 pi. Omega t plus delta is increased by 2 pi. That is, a sine omega is common from 2 pi and omega t. Then we can write t plus twice pi by omega plus delta. It is a sine omega t plus delta. This is equal to a sine omega t plus delta. That is, twice pi by omega is the minimum time after which the motion repeats. This is called period of the simple harmonic motion. Therefore, the period of the simple harmonic motion t equal to twice pi by omega. Now we see the phase of a simple harmonic motion. The displacement x equal to a sine omega t plus delta, and the velocity v equal to v max cos omega t plus delta, a equal to a max sine omega t plus delta. The displacement, velocity and acceleration of a simple harmonic oscillator depend on a common term omega t plus delta. Everywhere it is omega t plus delta. The common term omega t plus delta determines the velocity, displacement and acceleration of a simple harmonic oscillator. So it is called the phase of the simple harmonic motion. The phase delta equal to omega t plus small delta. This is capital delta. It is the phase equal to omega t plus delta. Therefore, phase is a function of time. It is like the equation y equal to mx plus c. It is the equation of a straight line making an intercept delta with the delta axis. Here you see the graph delta equal to omega t plus delta. It is like y equal to mx plus c, where c is the intercept. Here delta is the intercept. And if we differentiate it with respect to time, that is d delta by dt equal to omega. Here is also dy by dx equal to m. From this we can define omega, the time rate of change of the phase of the simple harmonic motion is called the angular frequency omega. In other words, the angular frequency of a simple harmonic motion is the time rate at which the phase of the simple harmonic motion changes. The phase of a simple harmonic motion is delta equal to omega t plus small delta, that is, it is the phase at time t. When t is 0, then delta equal to capital Delta equal to small delta. It is called the initial phase. It is the phase at time 0, that is initial phase. So delta is called the initial phase. We rewrite the displacement of a simple harmonic oscillator x equal to a sine omega t plus delta. Here the constants are a, omega and delta. A is called the maximum displacement, that is amplitude. Omega is the angular frequency and delta is the initial phase. Thank you.